Morning. Am I audible to you guys? Okay. So, okay, just wait for others for a while. So, okay, I guess some of you have already joined. I can just start. Yesterday I just briefly discussed about B plus tree. So today I'll just show the insertion process of B plus tree. Wait, let me just share the screen. Okay, so B plus tree is just a different version of your B tree. It's just similar to B tree. Everything is almost same. The only difference between B tree and B plus tree is that all the records are stored in the leaf nodes in case of B plus tree. And in case of B tree, we can just store all the data both in root or internal nodes and leaf nodes as well. But in case of B plus tree, we just keep everything in the leaf nodes, and the internal nodes and the roots are just the indexes for those records. So B and B plus tree we mostly mainly use for accessing the disk access. So the main purpose of your B plus tree is the secondary memory access. Okay, because every time we access a disk, the processing time is much higher if we use different data structure. But since B and B plus tree provides you indexing and multi-indexing concept, that's why they just use this data structure. So anyways, this is the example of your B plus tree. So the only difference is that you can see the leaves are connected through a link. It's just like linked list. Okay, this All the records we just stored in the leaves, and these internal nodes are nothing but your index for these records. Okay, so I guess I already explained you the difference between B and B plus tree. So main advantage is, again I explained it before in last class, mainly used for fast accessing of this. So just let's see insertion process. It will be easier for you guys to understand. Okay, so for insertion, we need to just take care of same things, like we need to find out what is the maximum number of children, what could be the maximum number of keys, and minimum number of children and keys. That's the only thing we do take care of. So there will be two steps, like if every element is inserted into the leaf nodes, we will just go to the appropriate leaf nodes. Otherwise, we will just insert key into the leaf nodes. So what will be the first case? That it's same like B tree. If leaf node is not full, then we will just insert the key into the leaf node in an increasing order. Okay, and what could be the case 2? If leaf is full, we just divide into half, then push it up. So let's just see once. I guess you guys already clear about B plus, no sorry, B tree insertion. Okay, so suppose I want to add values like 5, 15, 25, 35, and 45. So, and I want order of this tree to be 3, okay, or 2. Okay, for example, just I want order of 3. Okay, that means what? The process will be same. If order is m, that means what? Maximum keys can be in a node is m minus 1, which is 2. So suppose I'll add m first. Okay, so m is our first node. So obviously there will be two space for that node. Now I want to insert 15. So for 15 I can just directly put it here because I have a space and minimum number of key can be 2 for a three-way B tree. Okay, so next I want to add 25. Okay, now I want to 25. The process is same. The moment I add 25, uh, it's exceeding the minimum value or the maximum value, sorry. So what's the process for B tree? What's the process for B tree? What's the process? How we do it? We just find the median value, that is m by 2. For example, we just find the median value and push it up, correct? So what we will do, we'll do the same thing. So from here the tree will be 15. So same way we will split into two halves. The right side will be the right side will become the right children and the left side will become left children for this thing. Okay, 15 I push it up, so 5 will come here. Now okay, now the difference is that with the B tree, in case of B tree, I would have just split this up. 5 will become left and 25 will become right node. Right? But in case of B plus T, the same thing I'll keep a copy in the record as well. Okay? So that's the only difference in case of insertion. Why I did this? Because we keep all the records in leaf nodes only. Okay, that's why when I take the median and push it up, the same value will also remain in the leaf node as well. And I put 15 in the right. Why? Because it's a BST. For the binary search tree, left will be less than the parent and right will be greater than equal to the parent. Correct? So that's the one. Now again, and second difference is that all the leaf nodes are connected to each other. Okay, just need to point it out like this. Okay, now next is 35. Okay, now I want to add 35. So what will be the case? 35 is greater than 15, correct? So I'll go to the right side. So here I'll add 35. Okay, now again same case, it's exceeding the maximum key value. So what I'll do, I'll push 25 up. Okay, 25 up means I can directly put it here. Why it's so? Why I can directly put it here? Because there is a space there. Okay, it still has one key left out where I can keep this 25. Okay, this 25 I'll put it here. This will remain same. Okay, and this one will become this portion. I'll split it up, correct? So if I split this node, so 15 will become left of 25 and 15 is also like in the right side of 15. Then this 35. Okay, 25 I pushed it up, but it's a B plus tree, so same record will be stored in the leaf node as well. Okay, again same thing, leaf node, so I'll just put it connections. Okay, now again next node is 45. Now 45 is greater than 15, 45 is also greater than 25, so I'll come to the right side. Now 45 is greater than 35, so I'll put 45 here. Okay, so if I put 45 here, again same thing, I'll put the median up there. Okay, so just think 35 will be here. Okay, and 45 will be splitted. Okay, I just make another step. 15, 25. Suppose 35 is here, 5 will remain same, 15 will remain same. Now I am splitting these two portions, correct? If I split these two portions, means 35 should, just imagine, okay, 25 should come here and 35 I'll keep a copy and I added 45, correct? Okay, so the main stage will be what? Again it's a problem because in this node I just added 3 and key size is 25. So again I will take this median value, push it up, correct? I'll push it up, so 25 will go up now. This is 25. Okay, so if you keep 25 up there, that means what? Left child will become left 15 and this 35 will come to the right side. Okay, and rest will remain same. That means 5 is still there, then 15 is there, for 35 25 is here and here is your 35. Okay, so and these links are connected. So this is your final B plus grade. So is it clear to everyone how we can insert? The only difference with the B tree is that we keep a copy in the leaf node as well. And main all the records are just here. These are the main records, and these internal nodes and roots are just your index.
মেম
Hmm.
25 টো ওপৰত উঠি যাওঁতে 35ৰ ওচৰতো এটা কপি থাকিলে হয় নেকি?
কোনটো কোনটো?
লাষ্ট একদম ওপৰত উঠিলেতো হৈছে
25 to নে 35?
25 মেম তলত থাকিব নে নাথাকে মেম 35ৰ লগত?
35ৰ লগত কোনটো থাকিব? তলত এইটো নাথাকে। 35 টো থাকিব। ৰবা। Okay.
মেম এইখিনিৰ কথা কৈছো মেম ইয়াতে এটা কপি থাকিব নেকি 25ৰ?
ইয়াতে এটা কপি থাকিব নেকি? এইটো কপি নাথাকে কাৰণ কিয় নাথাকে? এইটো লিফ নোড নহয় ন, এইটো ইন্টাৰনেল নোডহে হয়, সেইকাৰণে ইয়াতে সেইটো কপি নাই। আমি
ঠিক আছে
লিফ নোডতহে কপিটো ৰাখো, হয় নাই? লিফ নোডত তোমাৰ 25টো অলৰেডি আছেই। এইখিনি ইন্টাৰনেল নোড হয়, চ' ইন্টাৰনেল নোডৰ কাৰণে চেম বস্তু এপ্লাই নহয়।
অ ঠিক আছে মেম মানে তলতহে হ'ব লিফ নোডতহে হ'ব।
য়েছ, লিফ নোড যেতিয়া আমি বনাম তেতিয়াহে এটা এটা কপি ৰাখিম।
আচ্ছা আচ্ছা এতিয়া বুজি পাইছো।
We
থেংক
keep
ইউ মেম।
copies only at the leaf node. That's why it's like that. Okay, so that's the insertion process for B plus tree. Everyone clear? Is everyone clear? Insertion. We are keeping these records only in the leaf nodes because all the records we keep only in the leaf nodes, not in the internal nodes. So when we keep copy, we just care about this portion only. Elements ground level पे होना जरूरी है. Yes, that's the main condition. वो ground level पे रहेगा. जो भी records है वो सिर्फ leaf nodes में ही रहेगा और leaf nodes will be just in your secondary memory. And these are just indexes. So in case of B tree, we keep records, roots as well as in internal nodes. But in case of B plus tree, everything is just in the leaf nodes or the ground levels. Okay. So the time complexity will be also log n because most of the tree has complexity of log n because height of a tree is log n. Just wait, someone came. Just wait for a minute, I got a call out. Okay, so this is all about your insertion. Now, I'll just briefly discuss about deletion. Deletion is also like same with B-tree. We always take care of what can be the maximum number of minimum number of key. Okay, so okay, let's. There's another tree which is red black tree, but that is not in your syllabus. But the recent trend, or I can say for the placement exams, they do ask questions from red black tea, tree, not tea. So I guess once the course is finished, means all syllabus, then I can also teach that red black tree also. Red black tree is also like your self-balancing AVL tree, just that it has extra color thingy. Means it also gives the record. अरे jadi हाँ raw. Yeah, so red black tree is also type of tree, just that it has extra uh, color information. So in a red black tree, your notes can be either of red color or black color. That's why the name is red black tree. So recently I have seen like um, in those competitive exams or placement exams, they do ask questions from red black tree. However, that is not in your syllabus. So once finished, I can just show some. So suppose I want to delete something from here. This is your 40, okay. So the approach is same. If you want to delete anything from the leaf node, okay, someone is at the lobby. Okay, so if you want to delete anything from the leaf node, and and in that node still there are the minimum number of keys, that means you can easily delete any node. For example, I want to delete 40. If I want to delete 40, I can just directly delete. Why? Because the minimum key is 1 and it has one key in that uh, tree, so we can directly delete it. Okay, so now let's see if I can delete something from a node or key which is has like just only minimum number of key. Now suppose I want to delete 5. Okay, now 5 I cannot directly delete. Remember in B plus T also we borrowed from either left or right subtree. Correct. So in this case also, we cannot directly delete the 5. So when you want to delete anything from the leaf nodes, it's the main record, then you also have to make sure the indexes are also deleted. Okay. In this case, 5 is there, but there is no internal nodes here. Of course, you will find 5 like you go to the root node, 5 is less, come to the left, again it's less than 15, come here and you will find the nodes. So in this case, what I'm going to do, I will delete this value and I'll take the maximum value from its right sibling and put it in the parent. Okay, so it's kind of exchange offer, you can just delete this one and you put this 20 up there, okay, in parent portion, then you split these values, okay. What will be the, I'll just show it from here, okay. If you do this, what will be the answer? 20 will come here, will go up there, and it will be splitted into 15 and 20. Okay, so what I'm doing in this node, 5 is the minimum number of key, so I cannot directly delete. If I want to delete, I will just take the one value from the right sibling. In the right sibling, I'll take the highest number, highest key. So this highest key, I'll put it in the parent, then I'll split this node again. Okay, if I split, so 15 will come here, 20 will come here, so 15 will become the left child and this one will become right child. Okay, so after this, what will be the value? Just write in here. 20 will be here, 15 will be here, and 20 will be here. Okay, so this is the deletion process if you want to delete anything from a node and it has minimum number of key. Now suppose the case 2 is like that, I just mentioned. Now you want to delete something from the leaf node, but there is also the same value in the indexes also. In that case, you have to make sure if you are deleting something from the leaf, then you also need to delete from the index as well. Now suppose I want to delete this 45. Okay, if I want to delete 45, you can see the same 45 is also in the index level, so I have to make sure this value is deleted too. Okay, if I want to delete the value, what I can do, I'll again take this 55 into this position, because we always keep a copy, the index will be like null, so I'll just copy this 55 value here and I will delete this 45 and will just keep it like this. Okay, so I'm just going to copy this value. That means I can directly delete 45, then I also will delete it from there. Okay, and I'll copy the value of 55 here because it has a child, right? I'll just keep the second value here. So what I did, I simply deleted that node since it has a trace in the index level 2. I'll just copy the next key from that node. Okay, so this is the deletion after your 45. Now suppose I want to delete 35. Okay, now I want to delete 35. Okay, if I want to delete 35, see there's again a press here, 35 is here, so I cannot directly delete it and I need to copy the second key to that place, but there is no second key in this node. This is the minimum value, so I cannot copy this. Okay, so what I'm going to do, I'm just going to borrow the same rule I'll follow here. I'll take the value from the its left sibling. What's the left sibling? It's 30. That means what? If I want to delete 35, I also need to delete 35, correct? But here there is no key left out so that I can keep the copy here, just like I did in this case. Since it doesn't have any key, I'll just carry the maximum value from your left sibling. Okay, so that means this 30 I'll copy here. Okay, and then I can delete. So what will be the answer? If I copy 35 here, means 30 will come here. Okay, I'll just copy this value here, so 30 will come here. Okay, then since I copied this value, so I just need to split it up, because you can see I cannot keep 30 here. I just need to split it up. Ah, wait, 35 I wanted to delete, right? So 30 I keep it here. So this 30 value I'll copy here. Okay. This is the deletion for 35. What was the value before? The value was 35 and 55, correct? And 25 was here and 30 was here and 35 was here. Only one key and 55 was here. Okay. So since I cannot directly delete the 35, it has index here. To delete this portion, I need to delete this portion also, and it doesn't have the second key, so I'll just borrow the value from the left sibling. It has a value, so I'll just keep the value here. Just keep 30 here. 30 will be deleted from here and it will be replaced here. Okay. So this process I just did it here. So this is our final. Now suppose in this case I want to delete 25. Okay. Now you can see if I want to delete 25, मैम 30 to 30 के राइट में मैम then but that there will be two type of black 01 and all and red black tea. Yeah, it can be different, but again there for red black tree I'll come to this point later because their leaves are not like normal leaves here, they just write mean values. Okay. Anyway, so for this one 30 equal to 30 to 30 के लाइट में 30 आ सकता है क्योंकि 30 के लाइट में तो 30 ही बड़ा हाँ सो मतलब यहाँ पे तो 35 यहाँ पे तो वो तुम्हारा वो था ना 35 था ना मुझे यहाँ यहाँ पे तो पहले 35 था 35 को डिलीट करना है तो 35 को डिलीट करने से यहाँ पे ये 35 यहाँ पे था तुम्हारा ना it's blocking the view 35 यहाँ पे था so 35 I cannot directly delete क्योंकि एक ही नोट बाकी है so I'll just borrow the value from यहाँ पे 30 बड़ा वैल्यू है so मैंने 30 को कॉपी किया फिर यहाँ से 30 को डिलीट करके ये 30 को ये वाला नोट में रख दिया so it's still maintaining the property of b plus 3 and 30 को यहाँ कॉपी कर दिया so सेम ही किया 30 यहाँ पे था तो 30 का वैल्यू मैंने यहाँ पे कॉपी कर दिया यहाँ पे डायरेक्टली फाइनल वाला है कॉपी कर दिया और इसको यहाँ पे ला दिया यहाँ पे 35 था तो 35 वैसे डिलीट किया ओके So abhi suppose I want to delete 25. Okay, I want to delete 25. Now you can see 25 is also the root. So if I want to delete 25, that means I have to make sure there is no index left in internal nodes as well as your root. So how to delete this one? Okay. Now thing is, and there is I cannot borrow anything because there is only one white child, correct? And I cannot take any key from here. Why? Because it has the minimum number of key and that key I cannot borrow. And of course, again, it's in the root side. Okay. So what I'm going to do, I'll simply first, suppose I have just deleted this value. Okay. Just think I have deleted this 25. Then what I'll do, of course, we need the root here, correct? So what I'm going to do, this 30, the children of 25 is 30, right? So I'll just take this value to your parent node. So what will be the final node? Final node, that means what? You are going to just keep this 30 here, and because if you want to delete 25, you need to delete this 25 too, right? Suppose you deleted 25. So this, there is a space, you need a root. So you will just copy the children, the highest one, the highest value you will copy here. Sorry, not highest. From the right side, we take lowest value. The 30 you will put it here. Okay. If you are going to take right, from the right, then take the lowest. If you are going to take from the left, take the highest. Okay. So 30 will come here. I can directly delete this node now. I can just directly delete this node now, and there will be no 35 because 35 I'm keeping it here. Sorry, 30 not. So there will be only one node here. Why I didn't keep copy? Because it's just internal nodes. I don't care about keeping any copies there. Main information should stay, all the records should stay in leaf nodes only. So there was a connection, you can just directly keep the connection here. So this will be your final B tree after deleting different nodes. Okay, for deletion also I have keep all those records here. So you can see, okay, it is just similar to B tree, just that in this case we don't need to, like when we delete something, we also need to take care that record is also deleted from the indexes. In B plus tree, we can just delete from anywhere, right? But in this case, whenever we want to delete something from the leaf nodes, that means we want to delete any record, we have to make sure all the indexes are gone too. Okay, so we have checked two cases here. Then there were sub cases. In case one, we deleted from the leaf node. In the leaf node, we had two keys and minimum number of key is one. So I can directly delete it. If not, means if it has the minimum number of key and I cannot delete, then we can just borrow from either left or right child. It's same like B3. If we have only minimum number of key, we are going to borrow the value from either left or right sibling. And the other cases we saw, if the value is in record and we also have the same index in the internal nodes and root nodes, then we have to make sure those records, those indexes are deleted too. In that case also, we again do the same thing. We can either take the value from the left or right sibling and keep a index in the internal nodes. That's all for today. I know because there are so many trees, the things are confusing. When you are learning, it seems okay, it's easy. But once I ask like from the middle, then everything will be like confusing because it's kind of same but yet different. Yeah, when I'm doing it, it seems easier. But if I ask just questions from the middle, then it's confusing. किसका क्या था, कौन सा बाइनरी ट्री था, कौन सा ट्री का क्या प्रॉपर्टीज था, वो कंफ्यूजिंग है. हाँ. So to वो confusion हटाने के लिए you have to practice yourself. Okay, I can give you some examples. So you can try at home by yourself. If you don't do it yourself, you won't understand. If you think I am just showing it and you will understand, no, that's not. You have to try yourself. If you don't try yourself, then you won't understand. And once you do it yourself, then only you will understand what what's not confusing and what where to confuse. Okay, I'll just give you some homeworks for the B and B plus T both so you can try. So for B and B plus tree, just remember in case of B tree, that's the main difference. In B tree, we can keep all the records both in leaves and the internal nodes. And in case of B plus tree, we keep all the records just in leaf nodes. The difference was in your इंसर्शन प्रोसेस. नॉर्मल बी ट्री में क्या था? We just keep 15 suppose 20 minimum की दो है. If I want to add one more value suppose 35, what I do, I find a median and push it up, right? So ये करने से क्या होता है? 20, 15 and 30, correct? This is for sorry, 31, I took here 31, 31. This is for your B tree. B tree में simple है, median को बस push up कर दिया, हो गया. But in case of B plus tree, what we do, we also keep the same copy here as well. So 20 भी यहाँ पे रह जाएगा. Okay, just don't confuse about this. But again, the second problem they need to last. This is only for the leaf nodes. If you are pushing anything from the internal nodes, it's not going to follow this value. You can just simply push things here. This rule that you will keep a copy in leaf nodes is only for your ground level, leaf nodes only. Okay? Any median pushing operation in the internal nodes and the root nodes won't be followed in there. Okay? You don't need to keep a copy. This rule is for only the leaf nodes. Just remember this difference. And in case of B plus tree, there will be a link between all the nodes in the leaves. हाँ, थोड़ा confusing है. So homework दूंगी, सब लोग try करना. If you don't try, कभी भी याद नहीं रहेगा, हमेशा confused ही रहोगे. और delete के time पे यहाँ पे एक difference है. Whenever you want to delete something, you also have to make sure indexes are deleted too. But in case of B tree, we don't need to care about that. If same values are that, we need to delete from the internal. ये फालतू. तो भाई कुछ वैसे. Okay, that's all for today. Time is up anyways. I'm just stop sharing. Okay, I'll give homework. You can just try yourself. Just take attendance. Okay, it's done. Over. Oh yeah, second half there might not be class, not sure yet because they said it might be a half. So if it's half day, then there won't be any lab classes. Okay, if no half classes, then yeah, there will be lab classes. Otherwise, no lab class. Okay, anyways, thank you.